and now you can hit start screen.
Yeah, we have to do SVG.
And in theory, it should only technically go on at the beginning of the event, but I don't know.
Yeah, that's
But it works.
And we should
Should
be
I
able to
pay attention to the camera?
I started with actually the HTML. Yeah.
I'm thinking
Down there. If I did a bigger show, yeah, if you want to see. You could ask me. That's your yeah.
Okay, welcome. So today we'll be talking about some basic technology that we kind of need to cover. For those of you who have a CS degree or have worked as a web developer, this is going to be very basic, but I hope there's some little nuggets that you also can learn today or that you just can remember of. And before I start talking about HTML and CSS and SVG, I'm also going to do a brief tutorial for Git and GitHub. Why do I do that? So first, this is like the survey responses that you guys filled out as part of homework 0. The first thing that I can tell is that about 30 haven't done that yet. So if you haven't filled out the homework 0 survey, please do that. It's important for us to have like as accurate a data set as possible. The second thing is like here we have the distribution of how familiar the class here is with Git, and you can see that like almost everybody has heard of Git or has used Git to some degree, but there is like a fair number of people who classified them as 3, 2, and 1. And so I think it's an important skill, not necessarily just for this class, but whatever you do, and I'm assuming that everybody here is going to work with code in some way to know your version control system well. And so I'm not going to use the graphical user interface for that. I'm doing everything on the console. That's how Git is meant to be used. That might make some concepts a little bit clearer. Yeah, and then afterwards, I'll give you a brief introduction into HTML. It's not going to make you like web designers, right? This is just going to give you some, like this is an element, this is CSS, this is how SVG works. And so, A, most of you should know that already, and B, this is not going to be enough for like, doing well in this class, so you'll have to read the documentation, and I've made an effort to really point to documentation a lot, and I will also like pull it up occasionally and we'll look at some of the references. Okay, so before we start, any questions about the class or there's homework 1 due on Friday, which you should be able to do after this lecture. I'm assuming it's not particularly difficult. Yeah?
So just with the game that we're having, it's not going to affect any of the posted hours that you have on your schedule, correct?
The game?
Yes.
football.
Football
Yes.
game.
No.
Just making sure.
No, like the TAs are not going to the football game, I assume. Yeah, so no, the game will not influence our office hours. Also, we have a homework lab scheduled for next Wednesday. So this Wednesday we don't do a lab because there's a grad student retreat for the computer scientists here, and also because we think that this SVG stuff, we don't actually need a lab for that. It's fairly easy. But next Tuesday, I'll be introducing JavaScript in D3, and then you'll have a homework about D3 due that Friday. So if you're not completely, don't feel extremely confident about your, this is going to happen, it's not in presentation mode. If you're not completely confident about your JavaScript and D3 skills, I would definitely recommend those planning to go to the lab. Okay, and then office hours are starting this week, so you can go see your TAs if you need homework, help with your homework 1. Any other questions? Okay, so then to follow along, here you're encouraged to actually pull out your computers and much like not the Git part, but all of the other parts are going to be interactive, so you can actually try it out live in this interface. And so you can find these tutorials if you go to dataviscourse.net/tutorials. There's also a link from our course website from dataviscourse.net. Just hit enter and then you'll find a link to that. And so we'll be covering today version control, HTML, CSS, and SVG. And then we'll continue next Tuesday with JavaScript introduction, and then DOM manipulation using the standard API, and then first steps in D3. So this is today, and this is next week. Okay, so let's start out with Git. So why should you use Git, or why should you use version control? So first, you want to be able to keep multiple states of files. So sometimes, for example, if you develop software, you might have an idea of trying out a new feature or of trying out a refactor, and that might be tricky to do if you don't use version control, especially if it doesn't work out in the end. So you have always a way back, especially also for creating alternative states. That's kind of like a related issue. So you can actually branch off a repository or a code base and do something with it, and then go back or integrate the branch or open multiple branches at the same time. Another important thing is collaboration. You will be asked to use Git and GitHub for your final projects, and so you will be asked to actually use these tools to collaborate in a team. And of course, why don't I want to just share code on Dropbox? Why is that a bad idea?
You can't keep track of who breaks it.
You can't keep track of, there's no blame feature, yes, that's an important part. But also, if two people are editing the same file, how does Dropbox handle that? It will save 2 versions and says conflicted copy 1, conflicted copy 2, right? And so that's not an elegant way of dealing with any conflicts that you might have if you work at the same file at the same time. Of course, you also want to keep your work safe. So I generally recommend that everybody here has a good backup strategy in place. I use multiple layers of backup, but one of them is definitely using version control on a server like GitHub. Your hard drive breaks, your computer is stolen, you forget your computer. If any of that happens, if you save your code, be it for homeworks or projects, to GitHub, then you can always access it. It's always safe. And then, of course, one very important point is, especially if you're an open source developer, Git and GitHub are good ways of sharing your code. You can make what you write accessible to a broad audience. You can get feedback, and can get bug fixes and discussions and so on. So when I started out with computer science, the only way of doing version control, or not the only, but the most common way of doing version control was a central repository. And what would happen, we would have at our lab, so there would be a server running that runs like a CVS or an SVN instance, and there's one big server that keeps track of all of the changes that anybody has ever made. And then the blue dots here are all of the clients that are working on that code at the same time. So this is a classic client-server model. You have one server and you have multiple clients. There's a couple of problems with that. Well, the benefit is it's easy. It's simple to set up. It's simple to write software that does that comparatively. All operations, for example, like a history command, a commit, a branch, and so on, requires a server connection. And it tends to be quite complex, especially for larger projects. So if you, for example, have a monolithic system like this, a key question is who has write access to your central repository, right? So you need to figure these details out. And it's also difficult for community projects. How do you apply changes that somebody outside your team made? And so, like, you can send around diff files, but that's not really a convenient way of doing it. And so, distributed version control is the alternative to that. And Git is a truly distributed version control system. And so here, everybody has a full history of the repository locally on their computer. So to go back to previous states, you don't actually have to have a server connection. You can do everything locally on your computer. There is no dedicated server. Like, conceptually, every node, be it your laptop or your desktop or the GitHub server in the cloud, are equal. So they run essentially the same software. Another pro is that you don't really have any access issues. So when your repository is available read-only, you just make a copy of it and then hack away. And you don't, if you then want to reintegrate it with the source repository, you can ask the owner of the source repository to look over your changes and merge them in. So all of this is quite useful. It's also fast. You don't require an internet connection. Another thing that is really encouraged, and that I really encourage, is this commit often model. So whenever you make like an atomic change in terms of like implement a small feature or fix a bug or anything like that, commit. Don't push if you know GitHub. Just do a commit locally and then write in useful commit messages. And therefore, you have good control of where something went wrong if something goes wrong. And then, of course, the negatives are, it's a little bit more complex. So, like, of course, writing Git is more complex than an SVN client, but it's also, you have to distinguish between commits and pushes and pulls and heads and so on. And so, it's a little bit more complicated. But I think overall, it's worth it. And so, there's like a couple of historical implementation. CVS is barely used anymore. Subversion SVN is still unused, and there's a professional tool, Team Foundation server, and the distributed ones are Git and Mercurial. And Git is much more popular, and we'll be using Git in this lecture, and I would recommend that you use Git or Mercurial for much of your work. So Git was created by Linus Torvalds, the creator of the Linux kernel, in 2005, and he gave it like this name because it's British English slang for an unpleasant person, and he also calls it Git, the stupid content tracker. And then I like this quote by Linus, I'm an egotistical bastard, and I name all my projects after myself, first Linux, now Git. So why do we use Git? Well, it's immensely popular. Like, I'm updating those lecture slides every year, and the numbers are just keep growing. So about 70 to 80% of searches in Google about any version control system are now about Git. And similarly for questions on Stack Overflow, you can find a more detailed analysis behind that link. Git is truly distributed, it's very fast, everything is local, it's open source, it's also free, as in beer, but also free as in freedom. It's safe against corruption, and of course GitHub, which is free as in beer. Like basically using Git and GitHub is like a proven method of managing software projects. Okay, so basically I just wanted to sketch briefly how Git works, and I'll do that over here. I hope everybody can see that. So you start out, like this is me. Here I have my computer, and then I'm hacking away. I'm starting like a new Git repository. I'm calling it A. So here I'm essentially initializing code. Like I created, or I initialized a repository. So this is an empty repository now. Then I start adding a couple of files and editing them. Then I commit again, and then I get to state B. Okay, and so now I can switch between A and B locally on my client. I can do some edits. So here I'm just changing any files, I'm not adding anything new, and I'm getting to a new state C. Okay, so this is all local. I have this version control system, I can hop between those. But now I want to back this up, let's say to a Github server. So let's draw like here a line symbolizing our network connection. And then we have like a server here. Okay? And now when I do like a push, and this is simplified, and in practice it's a little bit more complicated, but when I do a push, what happens is that you copy all of your stuff to the server now. Okay, and so now at this point, this is not G, this is C. Now at this point, your copy and the copy on the server are identical, right? So here I did commits, and this is now what's called a push. I could also sit on the server and do a pull from my computer, but in practice, what happens is most of the time you do a push. So let's say now Steve comes along. He also has like his little laptop computer. And so he wants to make a clone. So to do that, he clones his repository, and now he retrieves A, B, and C. And at this point here, all of those three states are identical. But now I am actually continuing to work here. So like I'm creating something new, so I get into state D. And at the same time, Steve is working on his stuff, and so he's getting to state X. And now, who gets write access to the server? Let's assume both of them have write access. Like what happens, what is important here? So whoever gets like writes first can essentially just write back to the server, right? So like let's suppose it's Steve who is writing back to the server. What happens, like he does a push. What happens is that the server now has state X. Okay? And so that is fine. This is completely synchronous between his state and the server state. But now if I wanted to push my stuff to the server again, then I would have a problem. So what would be the problem? We could have merge conflicts. And some of the merge conflicts, or some merges can be done easily, automatically, and some can be a little bit more complicated. So if I were to try to push here, that actually would not work. And so what I have to do first, I have to pull, and then I create this D plus X state that essentially where I have to either automatically resolve a merge or manually resolve the merge conflict. And then eventually I can push back to the server, and now I have the D plus X state here. And that's like essentially how you do synchronization on Git or Git and GitHub if this were your Github server. So any questions about this model? This is the same actually if I work with branches. If you replace Steve, server, and myself here with master, feature 1 and feature 2, it's the same model. So it really doesn't matter, it's just synchronization between different states. Yeah?
So basically I'm just thinking like if you have code D, but then you try to push it, and then you can't because there's X there, then you get D plus X. You have to basically start over from X, right?
No, yeah, well, so what happens is the Git will tell you you can't push. You first have to pull. And so then you pull X, and then you get into this merge state, where you are supposed to make sure everything still works, and you resolve any conflicts. If you worked on different files and different aspects, you might not have a source code conflict, but you could still have an integration conflict. But it's not that you don't have to start over from X. It's like the Git actually combines the two pieces of code together. Any other questions? Okay, so let's do this in practice. So first, this is one thing that you might not have done, but which I really would like you to do for your local Git instance. Git config username, git config user email. And why is that important? Well, it's important for us if we review your project. We always want to see who did what. And by setting this up correctly, we can actually see whether you all contributed roughly equally to your project. This is usually only a problem for one team or something like that. But by doing this properly, you kind of like make sure that you get your fair share of contribution. And we hear the excuse, well, I have actually used my friend's GitHub account and so on. This is really not how this is supposed to work. Please use your own accounts and please properly initialize your username and your email address, or your name and your email address. Okay, so I'll be doing this live here. I hope everybody can read the code up to here. So I'm creating a repository with make directory, and then I'm changing directory into my repository. As you can see, this is empty. And so now I'm initializing a Git repository. And so I have initialized an empty Git repository in my project. Okay, so that is not particularly exciting yet, and if I just look at what is in here, there's still nothing. But then if I actually look at the hidden files, I can see that there is a .git directory, a hidden directory. And this is where Git stores everything that it does, and all the history and so on. And so you could now take a look at what is in this repository. You see there's like a pointer to the head, there's a config file, there's a description, and then there's some other stuff. The most interesting piece here is actually the config file. And so here, this is something that you sometimes, like if something goes wrong with your repository, this is a good way to look at whether everything is set up correctly. This is not particularly exciting because I don't have any remote servers and so on, so this is a fairly boring config file. Here would be an example of a more interesting one where you have a remote origin. Like basically here I have like an old version of the website in this repository. So that tells you what are like other copies of that repository essentially. That's kind of like a shortcut for you to be able to quickly communicate with those repositories. So now let's create a file. Echo hello world into demo.txt. So this just writes hello world into this file. And then cat shows us the content of the file. And so we can see that hello world is actually written in this text file. Now we can add it to version control. Okay, and now we can check out what Git thinks. So we see, okay, status of Git is we are on branch master, there's no commits yet, but there are changes that Git is keeping track of, in this case, this new file, demo.txt. So before I actually save anything to the repository, we actually have to commit it. So I do that by running git commit, and if I just hit enter now, it would pop me into a text editor to enter my my commit message. But I usually do this -m, which means I put my commit message directly on the command line, and I could say committing the test file. Okay, so now I see I have one file change, one insertion. We have created a new node mode, or we have created this demo.txt file in GitHub. So now we change the file again. Are you still spinning? And here I'm using these double greater than signs to say that I want to append this to the text file. And if you look at this, you can see that now I have both of those lines in here. So hello world and are you still spinning? And now, of course, Git doesn't really know about that yet. So if I run Git Status, I can see it knows something has changed. So demo.txt is modified, but it's not tracking it at this point, this change. So if I now commit it, So what's going to happen now? It says no changes added to commit. And so what Git wants you to do, in addition to committing, is it wants to explicitly tell it which of the files you want to add to this change. So now we can switch the branch by running git checkout draft. And now Git will tell us that it switched to branch draft, and we can see that the file is unchanged. It's like an exact copy of this previous file. Now we can edit it. Let's say spinning round and round, and append this to demo.txt. And then if we look at demo.txt, we see it's here. And now we can commit. Okay, I did A and M so that all of this worked in a single line. So we now have written the changes to the draft branch, but the master branch should be unchanged. So if we git checkout master, and then look at demo.txt, we see that like this spinning round and round is missing from that file. So now let's suppose we are going to change this file in the master branch before merging anything into this branch. And so here I'm going to use a proper text editor because we want to change something here, first line, and then. So I've now added something to the first line and to the last line. Okay, I'm saving this file, I'm closing this, and now I'm committing it. Okay, and now I have two conflicting states, right? I'm kind of like in this situation that we had before, where Steve has version X and I have version D. And now we need to kind of like synchronize between those two. And now if I were to git merge draft, and that's the comment that I would use to say, hey, please change everything that's in please merge everything that's in branch draft into my current branch. And I'm currently on master, so the destination is defined by where I'm currently at, and the origin is defined by me putting explicitly the branch in here. And if I do that, it says auto-merging demo.txt, but I have a conflict. So I have a merge conflict in demo.txt. So let's look at demo.txt. We can see like this violet and blue markup here is just about the editor, the text editor here puts in, but like the raw file is actually first line hello world, are you still spinning? So it like merged the first line without a conflict. It could this doesn't work on line numbers or anything like that, but it's much smarter than that. But then it sees, okay, in the fourth line I have two different versions. Once I wrote of course I am, and then once I wrote spinning round and round. And now I have to manually resolve those changes. And I could say like here, just use the one or use the other. I can just edit this stuff, right? But I can also just remove these, like this markup, and now I will have the whole file combined. Okay, and so if you look at this now like this, we can see this is our merged file. And now I simply have to commit it again, resolved conflict. And now we have integrated between those two different branches. And this is like what happens a fair bit. If you work in a team, you will have to review those changes. And quite often it's easy to do that, but sometimes you have to really look a little bit closer. So everything here is back in order. If we run Git Status, we see we're on branch master, there's nothing to commit, our working tree is clean. So any questions about this so far?
Git Push,
Yeah, I'll talk about GitHub next. Then, like basically, push is just a shorthand for working with servers. I'll talk about this in a second. So now we've only worked with local copies, right? But the principle between these branches and so on is the same as with servers. So sometimes it's quite useful to actually, if you work in a software project, to ignore certain files and folders because like Git will always bug you. There are certain untracked files present and so on. And so you can tell Git there is a .git ignore file where you can specify which files never to add to Git. So here I took the git ignore file from the course website. So you see this is a Jekyll website and it uses this _site directory to dynamically generate HTML. And I don't want this dynamically generated HTML stuff in my Git repository, and so I add this _site directory. And so nothing that will be in this _site directory will be ever committed to GitHub or Git. And then here are a couple of specific files. These are metadata files that usually like an IDE or something like that would create, or a transpiler when you use things like Sass or TypeScript. These would like use things like that. And then here's some other ones. And you can use these qualifiers. So here I'm telling it any css.map file should never be added. So this is like an easy way to keep your directory clean. So now let's talk a little bit about working with GitHub. So here in my example on the whiteboard, I started out with my local copy. This is fine, it's possible. I think it's slightly easier to simply start with a Git, like a remote repository. So I go to github.com new, and then I can create a demo repository. I'll make it private, and you should have private repositories. Like if, for example, you want to push your homeworks, you should also make sure that you have private repositories. You can get this with your edu email. And then usually here, you should put in a README, and you should put in a license. I'm going to skip that right now, but these are important steps. So I'm creating this repository. Now I have created an empty repository, and I can simply copy the URL of this, and now run git clone, and then access that repository. And now I have actually made a copy of that online repository, which is essentially empty, or which is completely empty, onto my local computer. And if I go into demo, I can see there's nothing in here. But if I look at the config file here, you can actually see this is where remote origin is what the GitHub server in this call is called from the perspective of my computer. This is where like the URL of this particular GitHub repository is found. Okay, so here in this instance I had created a license and a README, but now I can actually like do again echo hello world into demo.txt, git add demo.txt, git commit added -m added demo. Okay, so now this is local. And now is the new part. Like when I now run git push, it will actually write to the online repository. So it's like it says here to https github.com lxsb demo.git. Okay, now I can actually go to that online repository and refresh here, and then I will see that demo.txt is suddenly appeared here. Now I could use the inline editor at GitHub. And then commit those changes here. And this is similar to like somebody else making a change. It's not tracked on my computer. And now I can git pull. And I will pull in the changes that I made to demo.txt. So if I look at demo.txt, you can see that I have now the synchronized changes from the online server. So this is like, and conflicts and so on work exactly the same way as I showed it before. And so the GitHub server here is really just another instance of Git, or another, you can think of it almost as another branch. I did like one shorthand here is by git pull assumes that I'm Git pulling from remote origin. I could also pull from other repositories, and if I wanted to pull from another repository, I would have to specify this other repository here. Does this answer your question? Okay. Any other questions? So one thing that I also like about GitHub is those two features. Like issues are kind of useful to keep track of open tasks. So you would create a GitHub issue and say, hey, I need to implement this feature, or hey, this is broken. And then if you write a commit message, you could do something like git commit -a-m fixed nasty bug discussed in number 1. So if you reference a ticket like that, it will actually close it for you. It will learn, it understands that fixed number 1 means like you're supposed to close it, this issue, and it will associate the commit with that issue, so that you can always look up where you fixed something. Or you can also say working towards number 1. It will not close it, but it will keep a record of which commit is in support of a particular issue. So that helps you structure your work and make it kind of like understandable after the fact. And then another thing is forking. So forking is essentially just branching, but from a repository where you don't have write access. So you could go to, let's say, github.com d3, and then this is an organization, and so you will see the core d3 repository. And if I clicked here on fork, I would create a local copy of d3 in my GitHub repository. And then I could clone this repository from my local computer, change it, commit it to Git, and then eventually bug my post, okay, I've fixed all of the problems that d3 ever had. Please merge them back into the core, into the source. And then they can review any changes that you made and say, no, this is stupid, or yes, this sounds great, we'll integrate it. Some of you might be using graphical user interfaces to work with Git. There's essentially two ways to do that. There's GitHub Desktop, which is essentially a graphical user interface to work with GitHub. So you can download it for your operating system here. I personally don't like it too much, but I know that people use it. Or you can use it integrated with IDE. So if you're using something like WebStorm or Visual Studio Code, that will usually have some of those features that you can just click on your project and say, push it to my server. It will keep track of changes and so on. And that is kind of convenient depending on how you like to work. So here I just wanted to show a way of you working with our homeworks that we publish, which we publish on GitHub, efficiently, so that you always get updates once we push them, so that any updates, if you ever discover a bug or a problem in our homeworks, that you can merge them easily into your homeworks, and that you can keep your own homeworks safe in a private repository in GitHub. And so to get the homework repository, you simply run this command here, git clone the whole homework repository. So let's do this. And then one important point here is this -o homework. This essentially tells me this -o is the origin. This would be where if we just have one GitHub repository, this would be usually your remote. But here I'm telling my origin here is homework instead of remote. So let's run this. So I've now cloned the homework repository. And the interesting part is, of course, as I just mentioned, is that we actually, if you look at the config file here, it says not remote origin, it says remote homework. So that's just the name that we gave it, right? Our origin is the default name. Okay, so now we would create a repository in GitHub. You could create my database homework repository on GitHub. And then, of course, please make sure this is private so that nobody can steal your code. And then you would run those two comments here. You could say git remote add origin your private repository. And so notice that here the origin is kind of like this repository, the default repository, right? So if you're pushing, if you just run git push, this is where it will push to. And then if you then, you also need to run this command, but if you then make any changes to your homework, you simply git commit and git push. And so therefore, like this will synchronize with your private repository, but will not touch our repository. And then once we release new homework assignments, or when we fix a bug in the homework announcement, you can simply run git pull homework master. And that will get you all the latest changes of the homeworks onto your local computer. And so, yeah.
What if we already cloned and we didn't use the is there a way to change?
Yeah, you can simply git remote add homework here. So essentially just replace that, like the order here. You can add the homework remote at the later step. So it's doing basically git remote add homework and then put in the official URL here. That should add that as a homework. Okay, so the other way to do this would be with forks, but this is one way of doing it. Any other questions about version control? This is kind of the end of the version control section. Yeah?
So what is the difference between a fork and
The clone is a command to make a local copy. Fork is not something that Git uses. That's a term that only GitHub uses. So fork is not a Git command. Fork is a GitHub command. So that means essentially on the GitHub server, make a copy of that repository. So fork is specific to GitHub. So if you use Bitbucket, you could use another term, for example. Yeah?
How do you access this web page? I can't find it on
databasecourse.net/tutorials. Can you guys post it on Slack? Or someone post it on Slack? Any other questions? Yeah.
So I did this, I noticed that some of the files that were in the repository are .md, and those look like they only open on GitHub.
MD are markdown files, and these are text files basically. You can just be able to open it up within a text editor. Markdown is essentially just a shorthand for like creating nice looking websites if you have a markdown renderer. And GitHub does have a markdown renderer. So if you look at, let's say, our homework, so let's suppose this is the markdown, readme.md. So I can click on that file. You can see this renders nicely with a header and like with a big header and with like boxes for code. But I can also look at the raw data, and this is what the markdown actually looks like. And that's readable. Like it's much more readable than, let's say, HTML, which you would use otherwise. And so here you see like this pound sign here is like tells it this is header 1 and so on. So it's a kind of like a simple markup to make like formatting easy, and you usually use it in combination with something like GitHub. But there's also like if you use an IDE like Visual Studio Code or WebStorm, they will show you the text you write and then how it looks like when it's rendered. Yeah.
So I actually forked the homework repository, but it doesn't let me make it private, the fork repository. So do I have to like clone it again?
Yeah, that's a good point. I didn't think about that. But if you do it like I just described, you will be able to kind of get around that problem. Okay, so then let's move on to HTML. So what is HTML? HTML stands for Hypertext Markup Language. And while this was like an accurate description when it was invented, basically as a document format, to kind of like describe how something looks on a page on the internet, it's actually a bit outdated. And so originally this was hypertext, and the key thing was that we had links between documents, right? And it's a markup language like Markdown, but it's a little bit more, let's say, powerful and flexible, but also a little bit more tedious to write than Markdown. HTML5 is kind of the current standard. Does much more than just being like a document markup language. It includes, you can do things like graphics, you can do with SVG or with Canvas or with OpenGL, you can do audio, you can do video, you can do interactive like basically the key point about it is it's not anymore just like creating documents, it's creating applications, and we can now basically build applications on the web as we like just 10 years ago could have only done on a desktop computer. And so that's why this is extremely powerful, because we can build a complex computer program and not have to install it anywhere, and never have to worry about updates. They will always get the latest version. And so in this class, we will be mostly building like these fancy web applications where we do data visualization. So you should think of HTML in a modern sense as like basically whatever the web browser knows how to interpret. And we will use HTML, CSS, and JavaScript to tell the web browser what to show and how to interact and how to render and so on. So the very basics of HTML are elements. You've all seen this, like an HTML element is a portion of the content that is surrounded by a pair of tags of the same name. So here strong would be a tag, and then here this whole thing is an HTML element. And so this here is rendered strong, and if I just added something here, you will see that this is not strong. And so this is emphasized, not emphasized. And so what you also notice here is that like the demos that I'll be using from now are all interactive. So you can change something and it will immediately render again, and you can play around with it on your own. And so I could, like, let's say, make this to bold instead of strong, which will look quite the same. So that's the basic HTML element. You definitely want to be able to nest these elements. So here I have a strong element, and then I have a nested underline element. Then this here is just strong again. Okay, and so like this is what this looks like. We start off with strong, and then here the underline part, and then again strong. And so the interesting part here is nested, and this is kind of like a tree structure that we can build out like this. In addition to the names of the tags, these can contain extra information about elements which are called attributes. And the most well-known is probably the hyperref, like anchor hyperref. We put in a URL and then some text to the School of Computing. So very simple again, and this is what this looks like. I could now click this and say open it in a new tab, and I would go to the CS homepage. Okay, there's many other attributes, and we will use them a lot. Especially we will use the ID, class, and the style attributes a fair number of times. Like ID attributes give your HTML element a unique identifier that you can then use to programmatically access that element, or just to style it. So we'll be talking mostly about styling today, but then next time we'll be talking about how can we use these IDs and classes and elements and so on to actually retrieve something from our HTML and change it dynamically. Most HTML elements have an opening and a closing tag, but some actually don't. So for example, if you have a line break, you don't actually have something in between them, right? So you simply have the break tag. And until HTML5, this is how they could either write break and then a closing break tag, which would be kind of like inconvenient. And until HTML5, this is what you had to do. This is the shorthand for a self-closing tag, so foo, slash, and then the brackets. But in HTML5, you actually don't have to do that anymore. You can just write break like this, and so you don't have to tell it it's self-closing. Which is, the reason for that is that because like HTML used to be an XML dialect, but that is no longer the case. So here's a list of some important tags. We have HTML, which tells us, like the doc type here, tells what is the what is kind of a document is it. Here we have the HTML tag that essentially tells that here begins our HTML code. Here we have the header. In the header, we provide some information that is not rendered directly on the web page, like the title of the website, or we provide some meta info, like the character set. And then we have the body, and so this is where we start rendering things. And so if you look down here, it's a little long. We start with this is a paragraph and so on. We can see we have a paragraph here, a break tag. Here we include an image. We use the image source tag for that. We provide an alternative like textual description of that image, and which you always should do because that makes it accessible to screen readers. This is how you would define headers, like headers of hierarchy 1, of hierarchy 2, and so on. You could do lists. This is an ordered list with list elements. You could do unordered list with list elements. You can create tables. Border is deprecated, so you shouldn't actually use that, but just so it's easier to see, I added that. And a table is defined by like defining table rows. And in those table rows, you can then define cells. These are either headers, like TH here, or table data, like TD here. So this is how the table looks like. So we have the header, and then we have the table rows with the table row with the cells. We can structure HTML without having it be visible by using divs and spans and other elements. Divs are divisions of a page, and spans are similar to divs, but they work inline. And so spans are good if you want to group a couple of elements together, but don't want to have essentially like a separation in space. You can also have forms where you can put in text. For example, here we have an input type text, and then I put in default text here, or I can have a text area where I can write longer text into the text area. And then finally we have comments. They look like this, and that's useful also like for writing comments, but also for just temporarily removing any code. So this is fairly straightforward. This is what a form looks like. We have a submit button that posts this. We're not going to use that too much. Okay. I think I talked about those enough. I think the one point that I didn't make is a link tag for the header. Links can be useful to reference external scripts or external documents, which are often CSS documents. So for example here, this is how you would include an external CSS document that's in a separate file. Okay, and so most HTML pages have some kind of necessary boilerplate, or every HTML page has some kind of necessary boilerplate. So this is like a minimal valid HTML page. And so I could open this up in a new page, and we could then validate whether this is actually valid HTML by either uploading the HTML to the validator, or there's also like a Chrome plugin where you can simply click on validate document, and in this case, like this button came up green, so that means this document is valid HTML. And so you should always make sure that your stuff is valid HTML before you submit a homework. Okay, so now let's talk a little bit about the document object model and how it relates to HTML. So HTML and the document object model in the case of this website here is basically the same. The document object model is the structure that the browser has of a page behind the scenes, but it's also a programming interface, like an API, with certain hooks that you can use in JavaScript to modify the DOM. So we'll not be doing that, but an important piece that you should always, that is going to be very important for you guys going forward, is to look at what is the document actually like. And so if you can right-click on the page or go to View, Developer, and then Developer Tools, you get into these developer tools. And here you see a representation of your page as the document object model. And so this is, like in this case, identical with what I wrote before, but when you use D3 or JavaScript to manipulate your page, this is the output. Like the source where you write JavaScript, where you use functions or loops or anything to create HTML does look quite different from the output, right? And so here you can look at what is it actually that you're generating dynamically. And what is also nice is you can hover over any of those elements and kind of like ask where is something. I can click inspect here and it will tell me this is the code that is responsible for this particular piece of code. And so here we have our HTML, and then down here we have the CSS that's associated with this. When I click on sources, I can actually look up the source code that generates that document object model. And in this case, they are identical, as I already mentioned, but here you would also find JavaScript files if you had them. There's a link to a good overview of developer tools here. So like this is a key skill, working well with the developer tools that I'm sure you will come to appreciate quickly. Okay, so this wraps up my HTML introduction. Now I want to move into the CSS. So the point of CSS is to separate style from content. Content of a website should always be in HTML, and style should be as much as possible separated from that. Because you can imagine that your content is consumed on very different devices. So be it your laptop computer, or be it your phone, or be it like a screen reader that somebody who's blind has to use. And if you do a good job at separating that, you can actually dynamically adapt to those different scenarios. We're not going to talk about responsive design, but it's good to know for you guys that by using CSS properly, you can actually make responsive websites. So what is CSS? CSS stands for Cascading Style Sheets, and they are kind of like these external declarations that control how elements will be rendered by a browser. Things like color, font size, positioning, and so on. We do only show the very basics here, so I would always recommend to use the Mozilla Developer Network web docs for any reference. So for example, most commonly if you type in something like h1 attributes HTML into Google, you will find these W3 schools, which are notoriously wrong in many cases. So whenever I do anything that relates to like a search on Google, I always put in MDN. And that will always get you to the Mozilla Developer Network reference API, and that is always correct, or most of the time correct. So you should really use this instead of any other resources. And like, I would also encourage you to read the documentation before you post on Stack Overflow. A style sheet usually consists of a list of CSS rules that are inserted with a style tag in the header. We can also do inline styles, or we can do styles in separate files. But the very basic style definition is like this. So we are in the header. Here, this is the same boilerplate as before. Here we have style, and now we write CSS. So notice that this is a different syntax as HTML. So here we have strong, and then all the properties of strong are the ones that are between those curly brackets. So background color and font size. And then here's some text, and here we have the strong element, and that part is strong. And so what you can see here is that behind the scenes, the browser matches this rule here, background color red, font size 300%, to this element here, and then makes it big and red here. So that's the purpose of CSS. This here is equivalent to the above, so I can have multiple declarations for elements. I can say strong background color and strong font size, and this will work just the same. So I can like break this up if I want to. There's sometimes reasons to do that. So these are element selectors. They match every single element. Most often you want to be, especially when you do data viz, you want to be more specific. You don't want to say every paragraph has that style or every div has this style, but you want to pick a specific div or a specific span or a specific group of spans, for example. And for that you would use class selectors and then later ID selectors. So let's talk about class selectors. Class selectors are specified by the dot. So here, for example, we have the class dot important. And so with that, we essentially tell for anything that we will label in our HTML as important, apply this style, font weight bold. So make the font bold. And then we have another class, which we call here footnote, that says font size is 75%. We want to make the footnote a little bit smaller. Okay, and so here we have a div, class important, and this is where we reference that style here. And then some text, and div class footnote, and then some other text. And then here I could use a combination. An object can be of multiple classes, so here we would have an important footnote. So this is bold and large, this is not bold and small, and this is small and bold, because I've applied those two different styles. So why is this a better idea than just defining those styles for every div independently, directly in here?
More reusable, and then you can also update it later on.
Exactly. It's much more reusable. And so usually it's a better idea to use these class definitions. One important exception is if you generate styles in JavaScript. Because then you get the reusability from JavaScript. So it's not necessarily bad practice to add style elements dynamically to HTML elements with JavaScript. But it is bad practice to write them in HTML. Here's an ID selector. For the ID selector, you use like the dot before it, you use the pound sign here. Like here we have pound header. And so here we have a first line, second line, and important. And this would look like this. So first line is font weight bold, color blue. Second line is font size a little bit bigger. And then important has a text shadow in a beautiful red color. And so what you will see is like now I have identified these three divs with these separate IDs. And so that's not usually how, like you wouldn't, for styling, you wouldn't do this with IDs. You kind of like rather do that to make it identifiable by JavaScript. Another important thing about IDs is that you can use it to link onto a page. So for example, here I have created a link that is just this here. Like this is all that is in my href CSS ID selectors, and this links to this element here on the web page. So if we actually inspect this piece here, I can see my h3, the heading, that CSS ID selectors has the ID CSS ID selectors, and now I can use this ID to refer to this part of the page. So if I click here on this link, it will always scroll to that page. So let's say if I click here, it scrolls to that page. This used to be the anchor tag, but now it just uses the ID. And so notice that I have like this pound in the URL here, which is pound CSS ID selectors. So that's what IDs are useful for. We also can use the combination of IDs and CSS to create a layout. So what we want to create is something like this. Here we have like a simple layout for a website, right? This is far from perfect, but we have like a menu on the side, then we have a footer where we put our copyright information or logos, and then here's the main page, part of the page where we would put our content. Like years ago you would do that with a table. Now, like 2 years ago, you would do it like I'm showing you here, and then I'll talk about how you would do it tomorrow a little bit later. But so here is how I could create that. I have a site, like a sidebar identifier that has a width of 30%, a height of 200 pixels, and it floats on the left. And I give it a color just so we can tell it apart. Then I have my body, the main content of the website that has a width of 70%, a height of 200 pixels. It floats on the right. I give it another color. And then I have the footer, which has a width of 100% and a background color of forest green. And then I write, like here is my nav ID sidebar. Like nav is basically just an element, an HTML element that tells a screen reader this is navigation, or that it's just semantics for a container that contains navigation information. We have our menu in here, then we have our main. Is another like more semantic element. Instead of it does the same thing as a div, it's just meant to be more semantic. Main ID main. This is the main part of the content, and then I have the footer, and same, I give it the ID footer, and then I create this layout. So how would I do this? Let's say if I wanted to create a website now, or like a release in, let's say, January. Anybody heard of a new technique? So there's a new technique, Css Grids. Grid layouts, and this is definitely the way you will do this in the future. And CSS grids are pretty cool because you can specify, like you've seen this probably in Bootstrap or any library like this, but now it's native in CSS, and you can create like complex layouts like this with CSS grids. So I don't want to talk too much about this, but if you like build it for your final project, for example, this is definitely the way to go. And there's some like. And the good part about this Mozilla Developer Network is that usually it also gives you information about how, which browsers to support it. And most browsers actually support CSS grids. It's not yet part of the official standard though. So any questions so far? Yep.
So, what is the actual difference between ID and platform class?
So an ID is supposed to be, it's semantic, it's supposed to be unique. You may use an ID only one time on a web page. It should be like a globally unique identifier. Think of it also as a global variable of your DOM. Like if, as in programming, if you like wrote a Python program and you have a global variable, an ID does much the same thing, make one item globally identifiable. A class is like, gives you rules for a whole group of things. So you could have like all the paragraphs of that class get this rule applied.
So this is mainly in reference to the homework one, but you talked about inline styling and kind of avoid that. So when you're positioning the elements and trying to create the paragraphs, you assign the inline width and height. And so do you want to abstract it out to the CSS?
So I'll talk, can I come back to the question I'll talk about SVG?
Sure.
Because SVG, this is all, what I'm saying now is valid for HTML. SVG is a bit of a mess in terms of how you represent visual properties, and so you actually can't do that. But I'll talk about it in a second. I'm basically almost there. So next I want to talk about like a little bit more complex CSS relationship selectors. So we had this example of element selectors, but we can also make more complex rules of what should match. So there are many different ones, but I just want to highlight two. This is a CSS Child Selector. That here essentially means P greater than B is the syntax for apply only to elements where B, like bold, is a direct child of P. So if I have a paragraph and then I have bold element in that paragraph, it will apply this style here, color blue. This here, but it's only for like direct child, right? If I have a paragraph and then a span and then a bold, this will not apply. Here I have a Descendant Selector. So that says any B that's within any div, that style will apply. So color green. And so let's look at an example here. Here we have some text and a B inside that, and so we see that this is bold and blue. And here we have this B not directly nested inside the P, but inside of a span, and therefore this is bold, but it's not. It doesn't match that selector here, so it's not colored blue. And then here we have the div B, the green one is a little bit down here. We have div span B, and that matches actually the rule of the Descendant Selector here, and therefore will be shown in green. Okay, so the child selector doesn't match, but a Descendant Selector does match. And so there's different ways, and these selectors, they're now useful for styling, but in practice, we will be using them a ton when we want to dynamically generate those DOMs. Like in D3, the first thing you do is select all and then a selector. And therefore, it's really important that you understand those selectors and that you understand them well. And these different types, element, class, and ID selectors. Okay, so I can create conflicting rules in CSS. And I can write multiple things. And usually what happens is the thing that is the most specific declaration wins. But what is more specific is kind of complicated. So there is a definition, but it's really hard to debug it. And so what you should do is, if you change CSS styles, what I would recommend is that you always go in and look at what is going on, and then you can actually like modify the CSS. Like you can actually edit stuff here in the developer tools directly. So you can see like I can change my HTML, I can add new elements, but I can also change the CSS. Now I could say, let's say, I'm kind of doing something wrong here. But anyways, you can change those styles here. I think I can't edit it because they're not, they are actually inferred and not ones that I am, like if I were to do this here, this should work. So here I have my styles. So here I see this is for the bold text. I have color green. I could change the color directly to red here or to white or anything like that. And I can dynamically essentially debug what is going on. And this is quite useful. Of course, you have to do that later in code because this is only temporary. There's other ways of declaring CSS. I already mentioned this external style sheets. Or here is an example of doing these inline stylings. So here I'm doing this color steel blue for this paragraph inline. And so I mentioned the pros and cons of that already. This is usually not a good idea in XML, but it's fine to do in JavaScript. Okay, so now let's move on to SVG. So before I do that, any questions about CSS? Okay. SVG are scalable vector graphics. And what is scalable vector graphic? What is the nice property of them? A, we can like zoom in and we will always have, never have a pixelated picture. It will always have like perfect resolution. And B, you can actually read those, right? It's like they have like a logical definition. So it very much looks like HTML with some special elements. And so here's a minimal SVG example. And so we have our boilerplate and then we put in an SVG. Here the width and the height attributes are mandatory, so you actually have to specify them for a valid HTML document. And this doesn't render anything, but if you look in the inspector, we will see that there is actually an SVG here. So now let's create a circle. Circles, and I put in the links to the Mozilla Developer Network documentation here. You can find like more details. I only give you some basic information here. Circle have an X and a Y position and a radius. And so here I'm saying in my SVG, add a circle at position 200 and 100 of radius 50. Give it fill gray, stroke steel blue, stroke width 5 pixels. And this is what I get. So here I have my circle of radius 50, so at position 400, 200. What is the coordinate system of SVG? Anybody know? So it starts in the top left corner. If I do this at 0, 0, see that the origin of the circle is exactly in the top left corner. So we start like X goes to the right and Y goes downwards, which is kind of like not the way at least I think about coordinates usually, but it's a common way in computer graphics. So now we need to talk about presentation attributes. This is kind of like to your question about styling and so on. So our circle has certain mandatory attributes like CX, CY, R, and here I used style information to fill in this gray and stroke, to fill in the fill, the stroke, and the stroke width. I can also do that with attributes. Not every of these style attributes, but many of them can actually also be specified like this. That's usually like not a great idea. You should usually use the CSS type definition. And another tricky part about that is that your CSS for SVGs has nothing to do with the CSS for HTML. So, for example, if you want to color a div, you would have to use background color attribute. But if you want to color an SVG circle, you will have to use the fill attribute. So whenever you look up how to style something in SVG, always make sure that you also look for the SVG specific solution and not get some generic HTML information. As far as like where to put those styles, for the homework, I would put them in a central CSS definition, but we're not going to be overly picky unless we specify that we would be picky in the homework description. An ellipse is specified by its position and the radius in X and the radius in Y. So very similar to a circle, X, Y, CX, CY, but then we have two different radii, RX and RY, and then we have our ellipse here. The rectangle, X and Y, width 200, height 100. Of course, this is now not the center, like for the ellipse and for the circle, it was the center, because we had a radius. For the rectangle, it's the upper left corner where we start drawing. Lines are specified using 2 points, so where we have to specify an X and a Y coordinate each. You also have to like say that you want a black stroke, otherwise you get a white line, and if you have a white canvas, that's not visible. Here we have 2 lines, one going from 3030 to 280, one going from 3050 to 150 and 120. And so in your homework, we actually ask you to create a line chart, once with a sequence of lines and one with a path element. You should really make sure that you do both. So this is the sequence, how you would do the sequence of lines. You can also do text in SVG. Like here is an example of how I would create some text. In SVG, I have this text element, specify its position. Like notice that like I don't have anything floating around here, or I don't have line breaks or something like that. I really position it at exactly that point, and this is where this is rendered. We talked about some graphical primitives, and this can get you quite far, so you'll be using a lot of rectangles and circles and text elements and so on. But if you want to do more complex shapes, you have to use the path element. The good thing is that if you use D3, this will usually be hidden from you. You have like line generators or path generators where you can put in a data array and that will generate the path for you, but it's still useful to know how a path works. And so here's an example of a path element, and this is like its own mini programming language down here. And here we have M, L, 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 C. And so what this creates is this curve here, like this goes these 4 line segments and then 1 curve. Okay, so let's look at what this does here. M means move my pen to coordinates 10, 10 without drawing a line. L means draw a line from your previous position to these 2 coordinates, so to 50, 10. So this does this line here. This L 50, 10 draws this line. Then this L 50, 50 draws this line here. This L 150 draws this line here, and 110 draws the line back up here. So that's fairly simple. It gets a little bit more complex if we want to define curves. And for curves, there's many different types of curves. I'm just giving you one example here. This is a cubic Bezier spline. And so for the cubic Bezier spline, I need to specify 3 points. So first it starts at the previous point. So the curve here starts at 110. This is this point here. This point is where the curve starts. Then we have two support points, 150 and 150-50. Like these are, like I showed them, I added them here as circles in red. This is this point here and this point here. And these are kind of like the support points of the Bezier curve that tells us how does the curve actually look. So if we were to move those over here, our curve would be something like this. And so these points are not hit by the curve, they essentially just parameterize the curve in this case. And then finally here, this last point is 150-10, which is exactly this point here. So this is where the curve ends. There's many different types of curves, many different types of defining curves. I'm not going to go into the details. There's a link to the SVG path element tutorial on MDN here. So if you want to play with this, this is useful. There's also another command, which I didn't talk about, Z closes a path using a straight line to the first point. So if I put in a Z here, it connects the last point to the first point. So I'm a little late, but let me just quickly say that ordering is important. Essentially here I start out running an ellipse and a rect in that order. And then what happens is that the stuff that I specified later is on top of the ellipse. If I specify the rectangle first and then the ellipse will on top of that. And then the last thing that I briefly want to talk about is grouping, because you will actually need it in your homework. Grouping allows us to, let's say I have these 4 points here, and I want to do a transformation, because I might want to move them all together and want to use a relative coordinate system, right? And so instead of having, and I might also want to scale them or flip them around. And instead of having to do the math here of doing this transformation in my head, I can actually use a grouping element here. So here this D packs all of the circles into one DOM element. So we now build the tree. And then I give this transform specification. And this transform specification has 2 parts in this case, translate and scale. So translate means I move it over by 200 pixels, and then scale means scale it in Y direction. And the result of that would be that now I can actually specify points on a coordinate system that starts at the bottom left. So that's kind of mentally easier to do. Transforms and groups are super useful. The scales are a little bit tricky because they apply to everything, including text. And so then if you do that, you would get this is how they read text in Australia, which is a little bit tricky. So usually what we do is we use these groups and transforms a lot. We don't use scales as much when we do data visualization. So this should give you all of the tools that you need to complete the homeworks. There's also an exercise here that you can do to play a little bit with that. And then I'll talk next Thursday, first fitting up exception, and then on Tuesday we'll be talking about JavaScript. Okay.